Hello all, my name is Krishnaik and welcome to my YouTube channel. So guys, this video is about stock market prediction and forecasting. We will be considering one company's stock price, and then we'll try to see that whether we are able to do the prediction and the forecasting by using the stacked LSTM. Now, one thing I really want to request you all guys is that please don't use this model for your personal investments. Just don't think that this model will give you any kind of profit, because understand stock market here. I've just tried it to do it by using stacked LSTM itself. I just wanted to show you how you can actually do it, but just don't use this in your real world life, so that you put some investment and then after that you lose some of your investment itself. So please don't do that. I request you all. Now let's go ahead and try to see how we are going to do this. Okay, we are going to use stacked LSTM, long short-term memory, and probably this video will be more than 20 minutes, guys, because I need to explain you step by step. In this, I have actually taken Keras and TensorFlow greater than 2.0. Okay, so I've used this libraries. I've used LSTM, long short-term memory, stacked LSTM. I'll tell you how we can actually create a stacked LSTM, and we'll actually understand. Now, the first step is basically the data collection part, guys. Probably for this, we need to have some kind of data, right? And I'll just show you all the steps that we will be performing. First of all, we'll collect the stock data. In this particular example, I'm taking the Apple data set, Apple company stock prices, from 2015 till today, till 25th. I'll try to take that particular data. Then we'll pre-process the data, that is divide that particular data into train test. Before doing that, we need to do a lot of pre-processing, which I'll be explaining. Then we'll create a stacked LSTM model, we'll train it, then we'll predict the test data and plot the output. Finally, we'll predict the future 30 days. That basically means the future 1 month from today's May month. We'll try to predict that, and I'll try to show you that the output, and we'll plot it also. So let's go ahead with the first step. So here is your data collection strategy, guys. Here I'm going to use a wonderful library which is called as pandas_data reader. If you really want to see what in this particular documentation you can go regarding pandas data reader, it provides a lot of libraries where you can actually access this kind of data. So currently I've selected Tingo. Okay, in Tingo you can see over here, it's pretty much simple. Just go into the Tingo site. Okay, just log in inside this, or sign up, and then you click on the API part. In API, you'll be able to find the key. If you go down in this particular section, in the authentication section, you'll be able to find your own API key. I will not share it with you guys because I'm going to use that for my personal purpose. And trust me, for 50, you can actually request 50 times in a day using this particular API. So it is a wonderful way that you can actually collect any amount of data that you like. Now, I'm going to import pandas data reader as PDR. Then guys, and this pandas_data reader will be already present in your Anaconda environment. Then you have a method which is called as get_data_tingo. Just give the stock price, this particular name, that is AAPL. For Google, you can write GOG. And the another parameter is basically your API_key. Okay, so just give this key name. This key name I've already defined over here, but I'll not show it to you guys. So you can execute this particular line and get your value, all the whole data frame inside your df variable. Then I will be saving this particular file in .csv. As I told you that we just have 50 requests that we can go ahead and hit it. But after this, you can again re-upload your data set from this apple.csv file, which you have actually saved, right? So below this particular cell, what I'm going to do is that I'm just going to write df.head and show you how the data set looks like. If you go and see the data.head, df.head, you'll be able to see a lot of features like date, close, high, low, open, volume, adjusted close, adjusted high, adjusted low, and many of them. You can take one of them, either close or high. In this particular example, I've just taken high. If you want to see from what date it is, we are having the date from 2015. And if I go and see the tail of this particular df.head, you will be able to see that I'm having this, dot tail. If I make it dot tail, then I will basically be having from till 22nd May. Okay, so I have the data till 22nd May 2020 for the Apple stock price. Now what I'm going to do is that quickly I'm going to take this close column. Okay, I'm going to take this close column, and for this particular price we'll be doing the stock prediction. You can also be you can also be able to do for other by using the same strategy and method. Okay, so let's go ahead and try to quickly show you how we can actually do this. Till then I'll just delete this cell because we don't require it. Okay, now what I'm going to do is that first of all I just want to pick up this close column, right? So for this, I'm writing df.reset index. If I do reset index, that basically means all this particular value will be going inside this. And then I'm just going to take the close column. Okay. So by this, I will be able to get all my close values in df1. So if I go and see the shape, it is having 1258 records. Okay. So if you want to really see the df1, I'm having these values like this. You can see that it is increasing as we go ahead till 1257, right? If you really want to plot this particular data frame also, you can use matplotlib.pyplot as plt and just use plt.plot df1. So here you can see that this is how your plotted stock price looks like, you know, from 2015 till 2020, right? So this is how your stock price is having the movement. It has both up and down movement. So let's see how we can actually solve this particular problem. Now, one thing that you need to note is, guys, LSTM are very much sensitive to the scale of the data. Now, in this particular data, this value is in some kind of scale. So we should always try to transform this particular value. In this particular example, we are going to take min-max scalar, where we'll be transforming our values between 0 to 1. So for this, I'm going to import NumPy, and I'm going to say from sklearn.preprocessing, import min-max scalar. In the min-max scalar, I'm going to take a feature range between 0, 1. Okay, so this is the value that you need to give when you want to scale down between 0, 1. Suppose you want to scale down between -1, 1, you can give that value also. After that, I'm saying that scalar.fit_transform np.array df1.reshape -1, 1. You have to do this particular step, guys, so that you'll be able to provide this particular input to fit_transform. Now let me quickly first of all show you how your df1 looks like, you know. So your df1 has values like this, 132, 131, right? All these values. Now after executing this step, you will be able to see your df1 will be now converted into an array, and it is now having values between 0 to 1. Okay, so it has got transformed between 0 to 1. Suppose if I try to print this value, let's see, you'll be able to see all these particular values that are there. And remember, this is between 0 to 1, all these values that you can actually see over here. Now, the most important step, right? Over here, I told you that we have done this particular step. I'm just going to write done. Okay, now we need to pre-process the data. Before that, let's go and do the train test split. Now, one important thing, whenever you're dealing with time series data, guys, understand. Suppose for the first day, the stock price was $120, then it came to 130, then it came to 125, 140. I'm just taking an example, guys. Okay, so 150, 160. Suppose this many information I have right now, right? Now, first step, what you always have to do during the train test split is that there are various ways of doing train test split, right? One is cross validation. Okay. One is directly by using some random seed. Okay, but these all methods, if I talk about these all methods will work very well when you have a linear regression or a classification problem. In case of time series data, guys, in case of time series data, we should try to divide the data set in a different way. So how do we divide it? First of all, what we do is that in our training data, what we do, suppose 70% of the initial data, and this should be ordered with respect to date. Okay, because understand, on day 1 this value was 120, on day 2 it was 130, day 3 it was 125. Now we can basically say that day 2 can be dependent on day 1, right? Similarly, day 3 can be dependent on day 2 and day 1. Day 4 can be dependent on day 3, day 2, day 1, like that. So we should try to divide this data based on date. Suppose I say that my 70% of data is here till here. So this before all the data is basically my 70% of the data. I can actually take this into my training data set. Okay, I can take this all into my training data set, and for the test data set I can actually take this. Okay, so this will actually be my test data set. Now I'll tell you why we are doing like this, guys, because after doing this division, okay, we will try to do the data pre-processing. But always understand that whenever you have any kind of sequence of data or a time series data, the next data is always dependent on your previous data. Okay, so you should always try to do this division in this particular way. So let's go and do this particular step. So over here you can see that I have taken an example. I'm telling that the splitting the data set into train and test split. So first I'll just take my train size. What should be exactly my train size? In this particular case, I'm saying that 65% of the total length of my data frame should be the training size. Okay. Similarly, over here, I say that my test size should be the length of the data frame minus the train size. So definitely, if train size is 65, then 35% will be actually my test size. Okay. Now, considering that, I'm going to use this particular length and I'm going to create my train underscore data and test underscore data. How? In df1, I'll say from 0 colon training size, that is whatever training size I'm getting over here. If you want to see the training size once I execute it, okay, I'll just execute it. Now, let me just show you what will be the training size. This is my training size. This is my test size, right? So these two values that you can see over here, 817 is my training size and 441 is my test size. So 0 to 817, I will get all those data from this data frame, you know, that index, you know, this is 0th index, first index, second index, like that. Till 817th index, I'll get inside all my training underscore data. And then remaining all the data after that, after 817 index, it will get stored in the test data. So once I show you over here, I've already executed this. If I show you my, the length of training data, so which is my train data over here, you can see that it is 817. And similarly, if I show you the length of test underscore data, it is 441. Now, if you want to see the training data, just go and type training data and you can actually see all this particular value, right? Similarly, test data will be the remaining part. You can actually print those values. Now, the most important step, we have done the train test split. Now, let me just go back to my notepad. Now, understand this is my data set. Okay, I'm just going to press enter so that we have some space. So I'm going to copy this particular data set in my training data set. Okay, so this is my training data set. And similarly, this is actually my test data set, right? This is actually my test data set. So this is my test data set. Now we need to do a wonderful data pre-processing. What is that data pre-processing that we have to do? Okay, so let me just show you. Now, understand, guys, this data that we have, suppose this is for day 1, day 2, day 3, day 4, day 5, day 6. Okay, so what I can do is that I will be now considering one time steps. Like, suppose if I want to compute the next day output, okay, how many previous day we have to consider? Okay, how many previous day we need to be dependent on? Suppose over here I take an example of 3. If my time steps is 3, then I will basically be having 3 features, F1, F2, F3. The first feature over here will be having the 100 value, sorry, 120 value. Remember, over here 120 is over here itself, so I'm taking it as 120. The second value will basically be 130, and the third value will actually be, or the feature 3 will be 125. Now, when I have this, then my output should actually be 140. Now, what we are doing in this data pre-processing, guys, we are just converting this into independent and dependent feature based on this timestamps. This basically indicates to calculate this, I need to consider the previous 3 days input, whatever input over here is there, right? Previous 3 days. Similarly, for the next, sorry, this should be 140. Okay. For the next record, what will happen? I'll just shift one position to the right. You know, now my new input will be 130, 125, and it should be 140, and then my output actually should be 134. So we will be actually doing like this. We'll convert this whole data set and convert this into our training. This F1, F2, F3 will be my X train. So I'm just going to write it down over here. So this will be actually my X train, and this will be my Y train. Pretty much simple, right? So these are my 2 data set. You can clearly see that independent features, dependent features. Now, similarly, This is my independent and dependent feature. Now, considering this data, I will try to use it in my LSTM model to train it, Then for the test data also, I have to do this in this way itself. In this similar way, I need to make this particular split, right? Suppose I have some more elements like 160, 170, okay? I've just taken some example, guys, so please bear with me in this. So, okay, here also I have to do the same processing, that is F1, F3, right? And here, this will be my output. Remember, whatever output this is basically my y underscore test, okay? And this actually is my y underscore. This is my y underscore train, right? So I have all this particular information clearly given to you, okay? Now, similarly, what I'm going to do, I'm going to write 160 over here. You will be able to see it. I'll be writing 160. First, my data pre-processing will have 160 over here, then 190, then 154, and then my output will be 160, right? Similarly, you can see that I've taken the first 4 elements. Now, in the next element, again, what will happen? If I see over here, it will just go over here. It will take the next 3 elements, 190, 154, and 160. The next output for this is, you can see, 170. So this will basically be my y test. Then what I'll do is that after I train my LSTM model with this training data set, I will take this test data set and predict it, and then try to compare with my y underscore test. And then we will be seeing that how good the accuracy is coming, how good the forecasting is actually coming. So we have understood this. The data pre-processing is pretty much simple, guys. I've created a method which is called as create dataset. Here we actually take the dataset, then under timestamp. In the timestamp, by default, whatever values you're giving, like 100, it will be taking 100 timestamp like this. Here in this case, it is 3 timestamp, right? So here it will be taking 100 timestamp. And remember, the more better you have a timestamp value, this is again a hyperparameter tuning technique which we will be selecting those timestamp values. So inside this particular method, that is create data set, what we are doing, first of all, we give out training data. Similarly, how we divided the training and test data on the top, right? Like how we explained over here. Now for this trained data, I am saying that, take the timestamp value as 100, okay? Make your data set as X and Y in this particular manner. This is the 3 lines code, guys. Understand, in the first iteration, you'll be seeing that in the 0th iteration, 0, 1, 2, 3 elements will be going as your first record, and your 3rd element will be actually, 4th element will actually be put up in the X if your timestamp is 3. If your timestamp is 100, like this, it will be happening for 99 elements, and then this will be in your X train, first record, and in your Y train, you will be having your 100 element, right? Similarly, in the next record, again, you will be starting from first element till 100 element, then 101 element will be going in your Y axis. So if you consider this particular example, I can consider like this. Let's see. So in the first F1, it will be like, how many features will be there? Somewhere around F100, right? So suppose it goes over here like 130, right? Like this, it will be going all the elements, and 138th element will be actually my 131, suppose I'm taking. Then my next element output, suppose it is 140, okay? Then suppose this was my second element, like 136, okay? Then what I can do is, then in next record, it will start from 136, and then I will continuously be having this output, okay? And the last element over here now will be 140, okay? And similarly, this particular element will be the next element, whatever we need to predict, or we already have that particular data. So we'll try to do in that particular way. And these are the 3 lines of code which will actually help us to do it, okay? Inside this, you can just check it out, guys. It's a very simple for loop over here that I've written. I'm traversing through all the data sets. I'm making sure that based on this particular timestamp, I'm putting that much data into my X and that much data into my Y, only single data into my Y, and I'm returning those values. Just check this, you'll be able to understand. I'm just going to execute this. I've got executed this. Now, if you will be see my X train, my per record will be having 100 features. This will be 100 features. Similarly, if you can see that, you can see over here, when I'm doing X train, let me just print the shape, okay? So if I print xtrain dot shape and ytrain dot shape, you'll be able to see that in my xtrain I have 100 features, in my ytrain I just have one value, right? And I have 716 records. So pretty much amazing. Similarly for xtest, you can see I'm having 340 records and 100 features, which are same as compared to the xtrain. Now we have got it in an amazing way. Our dataset pre-processing is done. We have completed basically this particular second step. Now the next step is basically creating a stacked LSTM model. So before implementing any LSTM, guys, we need to always reshape our xtrain. Reshape our xtrain into a 3-dimension. Now, what all dimensions are there? Understand xtrain and xtest both. So you know that these are number of records. These are number of timestamps. There should be one more dimension which will basically convert this whole shape into a 3-dimension. That is basically we need to add one. Okay, one over here. So you can see that I've written x underscore train dot reshape, x train dot shape of 0. Shape of 0 is nothing but 716. Then x underscore train of shape of 1. It is basically nothing but the timestamp. Then this should actually be comma 1 so that it gets converted into a 3-dimension. The reason why we are doing this is that because we will be giving this 2 as the input to our LSTM. If you have already seen my LSTM videos in my deep learning playlist, guys, you'll be able to understand it. So this is done for the xtrain and xtest. We have to also do it for that. Then I'm going to start creating my stacked LSTM model, right? Stacked LSTM model. So I have sequential, dense, LSTM. I'm adding this. Okay, these are my libraries that I'll require. LSTM model is pretty much simple, guys. We will be using a sequential model. First LSTM layer I'm adding over here, I'm giving the hidden layers at 50. I'm saying return to sequence is equal to true. The first input shape, as I told you, should be my this 2 values. Now I know that xtrain of shape is nothing but 100 comma 1. So I've given 100 comma 1 over here. Then in my next layer I had added LSTM. Again, this is a stacked LSTM model, one LSTM after the other, right? And finally I've added one more. After that, you can see that I've added one final output. Okay, and then I'm compiling with the help of mean squared error, and the optimizer is adder. Okay, so once I execute this, if I go and see my summary, this is my summary. After that, seeing the summary, what I can do is that, guys, I'll just remove this. This is not required. I have to just fit on my xtrain, ytrain, and the validation data that I'm taking is xtest, ytest. Epochs, I'm considering it as 100, batch size as 64. Let me just execute it in front of you. Now, you don't have to have a GPU laptop, guys. Even though you just have i5 or i7 laptops, you will be able to continue this particular execution. Even though I have a GPU, you will be able to see that, I'll be able to quickly execute this. Probably for me, it may take 1 minute. For you, it may take somewhere around 5 to 10 minutes if you have some good laptop. But since I have a GPU already, it will start executing quickly. Okay, so till then the execution gets over. I'm just going to go back over here. So I'm just going to provide the status over here. It is done. Create and stacked LSTM model. It is done. Now this needs to be done and this needs to be done. So I'm just going to write it as in progress. And remember, guys, here also it's all about Python code. What I'll suggest is that whatever logic comes up with plotting the output, it is up to you. Okay, this is all about logic. You have to come with some specific logic in plotting the test data, by using matplotlib or some other libraries. Okay, so you can see how many epochs is done, 16. Probably it may take another 1 minute. Let's see. Till then we will try to explore the next line of code. Okay, now after doing that, guys, we will try to do the prediction for the xtrain data, because we need to find out the performance metrics. So for xtrain also I'll be doing the predict. For xtest also I'll be doing the predict. I'll get those values over here. Then I'm also going to do the scalar inverse transform, because you understand that we have already scaled that particular. Now we have to do the reverse scaling, right? Because I need to find out the RMSE performance metrics, the root mean squared performance metrics. So for that, I'll be using the same object, that is scalar dot inverse underscore transform. And then I'm going to take the train underscore predict and get that particular value over here. Similarly, with respect to test underscore predict, I'm going to get that value over here, right? Pretty much simple over here. Now, the next thing is that probably let's see. Okay, 31 epochs are there. Still another 2 minutes max, I guess. Now what we are going to do, we are going to import math from sklearn.metrics. We are going to import mean squared error, which is the performance metrics, and then I'm saying that we need to apply root mean squared error. So for that, I'm using math.square root of mean squared error of y train and train predict. Train predict is basically my output for the train data set. So this, whatever RMSE is there, it is basically for the training data set, and obviously it will be good enough when compared to the test because we have already trained the data on the training data set. So probably we can actually get a good output considering this particular value. Okay, now similarly for the test data, I can again use math.square root mean squared error y test and test underscore predict. So here you can see that there will be definitely a difference, but the difference is very, very less, which is pretty much amazing. That basically means that our LSTM model has done a great work. It has done actually a good work. Okay, then you can see that I'm getting a value of 235. Now this is how we will be predicting this, guys. The test data predicted output that you see, that is basically my green color output over here. The blue color output is my complete data set, guys. For the training data set that you see, that how the prediction has gone is basically this orange color. This green color is basically my predicted output that you have actually seen for the test data. Okay, so this is basically my test data, because I told you that we are going to divide the data set in such a way that my test data will be, you know, after some specific date, right? We had actually seen in this notepad, right? After some, so this will basically be my train and this will be my test, right? So similarly over here, you can see that this green color that you see is basically my test data, you know, but still I need to do the forecasting. Till then, let's me see. Okay, 63 epochs are done, 64, it's going on. And you can observe one thing, guys, my loss value is not varying a lot now. Let's see from where it actually started. Okay, my loss, if I consider my loss had actually started from 0.02, then it is going lowering. Okay, it's lowering in a better way. You can also see the validation loss is also decreasing a lot. So I think we are going in the right way. We are going in the proper way, because our validation loss and our loss is basically decreasing, and our main aim should be that we need to minimize the loss. Okay, now for predicting it again, for plotting it, what we have to do is that, guys, I've just written this line of code, which is again pretty much simple. First of all, I'm taking NaN values everywhere based on the size of the data frame 1. Over here, my time step is 100. Okay, so considering this 100, what I'm going to do is that whatever train predict and test predict I've got, I'm just plotting it over here. Okay, I'm just plotting it. This all data that you see till here is basically my train predict data, and this is my test predict. And before that, always remember, you need to do the scalar dot inverse transform. Or don't forget about that, guys. You always have to do that, otherwise you'll not be able to get it in a proper way. So df1, you have to do this. This two already, you can see that test underscore predict and train underscore predict, I've already done the scalar dot inverse transform. This is pretty much simple code. Just try to have a look. It will you'll be able to understand it. Just download it. I've given you the code in the GitHub repository. So I hope okay, 92, 93, 94, but it's good, you know. It's I feel good that I'm actually working in my laptop, and quickly I'm able to train it. I'm able to explore a lot of things. From when I've actually bought this laptop, you know, I'm able to do a lot of work actually. So yes, last epoch, done. Okay, perfect. So this epochs have done. Now I'm just going to do this execution. Probably it's taking time. Okay, done. This is my, it has got reduced than the previous value. Okay, this is 235, which is almost same. Now we'll be plotting this, you know, we'll be plotting this. This is my test data output that I have predicted, considering this green line. This orange line is for the train data. Now remember one thing, what we have to do now. The next step, I told you that we have predicted the output, and this is done. Okay, so this is actually done. Now predict the future 30 days. Okay, guys, and for this again I had to write a lot of logic. Understand that if I go and see my length of test underscore data, guys, it is 441 records. So I have to actually I wanted to start from, if I consider, okay, suppose I consider that in my test data, my last date is somewhere around 25th, 22nd May. Okay. Now to calculate the output of 23rd May, I have to take the previous 100 days data, right? Then only I'll be able to predict my 23rd May data or output, by giving it to my LSTM model. So it's the same thing that I'm doing over here. Over here, you can see that what I'm doing, I'm taking from 341 to 441 data. That is my previous 100 days. And I'm reshaping that into 1 comma minus 1. So once I do it, you'll be able to see that I'm having 100 data over here. Okay, so this is also the same step. I'm just going to remove this. I'm going to remove this. Okay, now after this, what I'm going to do is that I'm going to convert that into a list. Okay, list, I'm converting it, and I'm actually taking all the values from there. So once I execute this, let's see my temp underscore input. Temp underscore input is basically all my values. All my values you can see over here. That is basically all my data from this test underscore data, right? These are all my test underscore data values. The previous 100 days, this is 100 data, okay? And then I have actually written a logic basically to find out the next 30 days. You can see that I've written a condition. While I is less than 30, I have to run this particular loops. In the first, this will go inside this, okay? So what is happening, let me just tell you what is happening inside this, okay? Inside this, what we are doing is that whatever this 100 results we are given, we are passing it to our model and we are doing the predict. And before that, we need to do this reshape that we always used to do, right? In LSTM, you can see that I told you that the first step is always doing the reshape, right? So here also we have done that reshape. So for the new data also, we always have to do this reshape. So this reshape, you can see that we have done over here. Then we are doing the prediction. I'm getting the y hat value. I'm adding this y hat value inside my final output. Okay, over here you can see that I'm adding it. And then I'm also adding it in my previous input. In my previous input, which input? This particular input, guys, whatever input I had in my data set, right? This is having 100 data. Now when I add into this particular list, it will now have 101 elements. Now I have to actually shift from one position and take the remaining data, and that is what I'm actually doing inside this if condition. I'm saying that if length of temp underscore input is greater than 100, I'm going to take from the one position. That basically I'm shifting one position to the right, and I'm taking the new output as and putting that into my input, right? So I'm doing that same steps over here, and I'm doing it reshape again, and I'm doing the predict. And finally, again, this condition will be going on unless and until we complete 30 loops, and probably we'll be getting this particular value in that specific way. Finally, once I execute it, you guys, I'll be getting all the output inside this list underscore output. Then now the thing comes is with respect to the plotting, how we can actually plot. So you know that from my test data, I've taken the previous 100 days. So I've kept 100 indexes inside this day underscore new. In the predicted underscore day, I have taken 101 to 131 because 30 days future I need to predict, right? So this will actually come in my x-axis. I'm going to use matplotlib. I'll come to this particular thing, guys, just a second. So I'm saying plt.plot scalar.inverse transform df1 of 1158. Now why I'm saying df1 of 1158? Understand, guys, the total length of df1 is 1258, and I've told you that I've taken the previous 100 data, right? I've taken the previous 100 data. So when I'm taking the previous 100 data to do the future prediction over here, so this 100 data will be having the previous 100 data itself. So I'm saying that from 1158 to 1258, you display that as my real data. Now my predicted data will be scalar.inverse transform list underscore output. This list underscore output is basically I'm adding all the output inside this, right? So when I do this, you will be able to see we are getting a wonderful graph which looks like this. Okay, this is the new 30 days output that you can see, and I think the LSTM has done wonderful work. Okay, but still, if you want to see the complete output, I would suggest is that just try to do in this particular way. combine your df1 and your list output inside df3 and just try to see how the prediction comes. Now you can see that at the end, this is my 30-day, and it will be actually smoothened, when compared to this zigzag way we had this particular stock price, right? It is actually smoothened, and you can see that it is also going up and down. If you want to really see in a proper way, just start from 1200. Now here you can see that how this data is, and here you have a good visibility with respect to this particular point of time, right? Like how the data or the stock price is predicted. So I hope you have understood this. Now how you can improve this particular model, guys? Instead of 100, try it with 150 timestamp. One more thing that you can do is that try to predict for the next 100 days and try to see that how it looks like, how the data, how the output looks like. The video, guys, I hope you were able to understand all this particular thing. So yes, this was all about this particular video, and we can still improve this accuracy by using bidirectional LSTM. So yes, and that I'll be showing you in my upcoming videos. So yes, this was all about this particular video. Please do subscribe the channel if you're not already subscribed, and please do share with all your friends, guys. Hit the like button if you like this particular video, and make sure you subscribe. So thank you one and all. I'll see you all in the next video. Have a great day. Thank you. Bye bye.